Okay, so I basically want to talk a little bit about our startup OrgPad and also about the tech behind OrgPad, which is everything is written in Clojure, which is sort of an amazing programming language in my opinion. So I want to share this. So we will start with this short presentation. This is actually done in our tool itself. We can share the link later and you can go through it. I won't go through everything. And then we can hook up some live coding and I can actually show you how it works in a real project. Right? Okay, so Clojure was released 13 years ago, so it's not a new thing. And it was done by work of this guy Rich Hickey, and it's a wonderful programming language. And what's amazing about it is that it's really different from anything else I have ever seen in my life. And it flips all the rules of programming languages, and when you flip all of them at the same time, it makes sense. If you try to flip only one of them, you will get garbage. So it's like you have to really change the way how you do. And this is from Richie's talk where after 10 years where he was actually talking that these problems were addressed by Clojure. These big problems of computer science are solved by going through Clojure. And if you would be interested in more, there is a PDF here which is a paper describing the history of Clojure written by Rich himself. So now, Rich Hickey is the guy who created Clojure, and he also, for instance, created his own different database called Datomic, which is completely different than the previous databases because it's immutable. It doesn't lose anything. So as you add more and more values, it keeps all the history. So that's amazing for certain types of business tasks. So basically this guy, he's also very different than most programming language creators because he's not a programming language creator. It was not his job. His job was, he was programming large information systems for several decades. And he got really frustrated by the way how basically the tools and the languages are limiting him, and he started to sort of twist them, and then he was struggling, for instance, with things like deployment, like how to get, I've written an amazing thing, but how to get it actually running in production, because people who do the running in production don't want to handle something like Common Lisp. So there's a story, also one thing which is interesting about him. So he also created first efficient implementation of immutable data structures. So one of his goals, because Clojure should be practical, it has to be fast. Because if you're too slow, then you can't use it in the real situations. And he wanted to program everything he was doing before large information systems in Clojure. So he had to basically invent how to do immutable hash maps. So you have a hash map which doesn't change. You can add things into it, but the original copy is still preserved, and it's really fast. It's sort of a magic of Clojure.
How fast is it?
I think it's sort of like 2x on read and 4x on writes, which is really good. But you can also parallelize things if you run it in. So basically, it's nowadays you don't have standalone processors. You have a lot of computers interacting over the same data, and then you can actually use this power. You can't use it in the traditional approach of locking and stuff like that. But basically, this guy is sort of an amazing speaker. I think if you want to do one thing after this talk, I would recommend you just go and watch this talk. This is Simple Made Easy. He actually explains the difference between simple and easy. And this was a talk given at a Ruby conference, so it's not Clojure specific. I think it can be applied to anything in computer science, and actually even outside of computer science. So when I was doing math in academia, I was actually also trying to bring the simplicity to math. because otherwise everything is convoluted and it's not clear what's going on. But if you spend a lot of time and effort, you can actually make math much simpler than it's taught nowadays. And the same stuff is with Clojure, that you can basically build a language in which you can build the same systems, but in a much simpler and more straightforward way. And the advantage is then you will understand them better, for instance. And they also can be even faster, because if you understand things better, you can make it better. You can make it faster. So, and the trade-offs are not so clear. Okay, so what is Clojure? So it's based on Lisp. Who here have ever programmed in Lisp? So yeah, this is a sort of like old, like, I mean, one would be thinking like Lisp is sort of like this ancient programming language. Like, who would ever use Lisp nowadays? Because, like, at least in my mind, I never met Lisp at university, and I actually met Clojure, which was the first Lisp 2.5 years ago. So I didn't know that much about it before. Yeah, I spent quite a lot of time programming in languages like C++ and Java and all of this stuff. But yeah, Lisp was basically hidden, and sort of the geniusness of this language is like it doesn't want to die. Basically, it always gets reinvented and brings back, and maybe in the future everyone will be coding in Lisp and it'll be really good. But basically, it was highly influential in 1958. I think it was the second oldest programming language, and a lot of programming constructs we are using nowadays, for instance, garbage collection was invented in Lisp. The problem was that the machines were too slow at that time, so it had to wait later, and then it changed programming. So I think sort of it was ahead of its time. Like, it's really like nowadays you can harvest its power and use it with Clojure, but at the time it was invented, the computers were not ready. Okay, so what is the basic syntax? Instead of writing function call like this, with f and the parentheses and the parameters divided by commas, just move the parentheses in front, and the commas are optional. So normally you don't write commas, you just write spaces. So this is f, the function f called with parameters x, y, and z. But the difference is that now we are doing programming within data structures. So the code is actually data. So it sort of looks like something like JSON. We're programming in something which looks really similar to that. And there are advantages of that. I don't want to go into the details, but for instance, when you have the data structures, you can actually transform them at compile time, and then you can produce new data structures. So you can easily write programs which generate programs, which is really beneficial if you do low-level library work. You can basically change the language if you want to. So there is this word homoiconicity. I don't think that's so much important that the data and the code is the same. They look the same. Okay, so it's also hosted, so it runs on different platforms. And that was to solve the original constraint that Rich developed some system in Common Lisp, and then when he wanted to put it in production, like, they told him, no, we don't want to run this, you have to rewrite it, and he spent some time rewriting it in C++, and the result was much worse, much slower, much harder to maintain, and he got really upset about it and decided, okay, let's solve this. So it's always hosted, you have the direct access to the host environment. So originally, Clojure was targeting JVM and also CLR. And nowadays, I think CLR should get some update, but most of the Clojure community runs on JVM. And there is also another version called Clojure script, which compiles to JavaScript. So within sort of one programming language with small changes, you can target both the browser and the backend. So you can basically, and you can share code between front end and back end when it's necessary. So we have some code shared in OrgPad, and it works quite well. And also a lot of situations you're solving in the front end are very similar to things you're doing in back end. You don't have to learn multiple tools. So just master one. And also it produces highly optimized code because it runs through Google Clojure compiler. This is a different thing. It has nothing to do with Clojure, with JNS. And it actually does things like code minimization, but also it eliminates that part of the code. So if you include a big library and it goes through Clojure compiler, you will get a small compiled JS file. So actually the entire Clojure script compiled is, I think, something like 20 kilobytes. So it's smaller than stuff like jQuery. And so much more powerful. So it's really not something heavy you will have to pay a lot. Yeah, there is this thing. It's actually used by a lot of companies, from startup to big companies. There's some quotes. I would basically agree with all of this. It's and all of these things are not programmer-centric things. Like, you might be sort of like, programming is a toy and you want to play with different toys, but in the end, if you do business, you want to basically produce high quality product as fast as possible and be able to fix it quickly and adapt it to new business situations. So you always want to be practical, and these are people basically saying how much Clojure is advantageous for them compared to Java. The code is smaller, we avoid mistakes, we understand the code better, we write it faster, and so on. I have to agree with this. I mean, in my experience, you have sort of two types of things you do when you do programming, but also elsewhere. Is like, you do things which are essential for your business, and then you do things which have nothing to do with your business, but sort of you have to do them because of constraints. Like, if you run a company and maybe you have to pay taxes and you have to do accounting and stuff like this. Like, this is nothing to do with your core business. Your goal is not to pay taxes. Your goal is to make a product and sell it, but basically you have to pay taxes because the state requires you to do so. So the same stuff is with programming. You do programming, and sometimes you do some core business logic which you really want to take care about, and sometimes you just play games with the compiler or with the libraries. Like basically they create you some puzzles for you and you have to solve them, like how to put types together and how to organize the code and how to organize modules and stuff like this. It has nothing to do with your problem. It's just basically invented stuff. And in my experience, Clojure minimizes the amount of stuff aside. Most of the time I'm thinking, when I'm coding OrgPad, I'm thinking about OrgPad problems, like what I want to show to the user, which data I want to get, how I want to transfer stuff, things like this. I'm not thinking about how to play the compiler game or stuff like this. And when I was working at Google, I think 90% of my time was lost by doing nonsense stuff like unit tests and fighting libraries and waiting for compilation and waiting for runs and so on. And Clojure eliminates most of these things, and maybe the ratio is the opposite. 10% of my time is lost by things I don't want to do. And sort of the feeling you get from this is absolutely amazing, because everyone hates to do repetitive stuff which doesn't benefit him. So you save a lot of time, and also you are much more happy. And there are actually some data that Clojure programmers are the most happy programmers in the world, because you can get more stuff done. Efficient immutable data structure. So all programming in Clojure is done with values, and value is something which cannot be changed. So when you create, say a vector or a map, it cannot be changed no matter what happens. The compiler is protecting you from any change. Okay, so but if you hear this, you might be thinking, okay, this has to be slow, because what if I want to add something? I can create a new copy of say a big hash map, but then I will have to pay because I will have to copy it. No, you don't. Because instead of programming with arrays, you program in trees, and it's done in the way that if you have this vector and then you decide to add new elements into it, it just copies a lot of stuff, because nothing can be changed. You can share the common structure. So basically adding something to a vector or a hash map costs only logarithm of the number of elements, which is for anything practical is less than 7, and you have terabytes of elements. So it's super fast. And Rich spent quite a lot of effort. Actually, these trees in the picture this is not coded in this way, they're much wider. So the branching factor is 32. So you have, if you have say depth 5, you have a lot of data in the tree. Yeah.
Is this more of a conceptual thing, or like in between state, or is the data actually held in memory like that?
Yeah, the data is held in memory like this. So basically, if you, if say you have this structure here, and you decide to add 6, so what you do is you will just create new blocks which contain things which are changed, and then you share the memory where it's the same. So this part here is preserved in both of the structures. So you can just share it. And he spent a lot of time of his 2 years working on the language, actually making this really fast.
Yeah, I can imagine, because of locality it's probably slower than like a normal array where values are next to each other.
2x to 4x. That doesn't matter. Yeah, it's really fast, and actually it's hard to compare it, because you can't compare the speed on this separate test. You have to think of the entire system. So what happened, a practical example is there is a Facebook library called React, which does the front-end rendering. And what happened is that in Clojure script, they wrapped React in the way that it was 30% faster. So then the people from Facebook came and was thanking to Rich Hickey that basically they're rewriting React based on his insights, and they're improving the library quite a lot and saving a lot of money. So basically, in the end, it can happen that if you do everything immutably, your system as the whole is running much faster. For instance, because it's simpler, or because you can do parallelism efficiently. Because these things, this cannot ever change. And if you know this cannot ever change, you can share it with as many threads as you want. You don't have to do locking. So this is the advantages you get, and it's really hard to see how to compare basically the speed of things, and normally we don't really have the data to say what's faster and what's slower, and if the system is really big, it's really hard to say anything about it anyway. Yeah, so it's like you can think of it like it's sufficiently fast for almost everything you will ever need.
So is it self-hosted, the Clojure compiler?
Sorry?
Is the Clojure compiler self-hosted? So is it written in Clojure itself, or is it written
so
in
it's
something?
part of it is written in Java, and it compiles to Java bytecode, and part of it is written in Clojure.
Okay.
And
because when you said that actually the Clojure script people
Clojure
react that.
Clojure
These data structures would have to be implemented in Clojure itself, right? Because otherwise.
They.
Or did they just implement the ideas separately?
Clojure script compiler is written in Clojure, and it emits JavaScript. So basically, big part of implementation of Clojure script was the implementation of these data structures, so they run within the browser. But implementation of that, what I heard, was not so difficult because they already had Clojure. They didn't have to do the Java bootstrapping. So that's quite good. But it's also if you do Clojure programming, normally the compiler runs aside of your program. So it's not like you write something, then you compile it, then you see the result. But it's more like you play and change the code while your server is running. And we'll be showing that. So it's like the loop you get is much more instant, and then the productivity is way better. Yeah, I don't think this is so important, but I think this is actually, this idea even scales to the size of entire database. So you can have an immutable database which behaves similarly like that. And I think this is sort of the future of databases. They will look like this. Why should you lose data over time? doesn't make any sense, business sense. Why? Like you normally care about the past and sorry.
GDPR.
GDPR is separate. There is evict mechanism which allows you to remove stuff from history if you really need to, but you don't do it normally. But if you work in Postgres and you want to have the persistent history of everything, it's a really tough problem to do it in Postgres, and you have to solve it in every business application. Why should you reinvent the wheel? So this is a sort of the intro of Clojure. I think there's some things like which I would consider non-problems, but some people care about them for some reason. One argument is there is too many parentheses. Actually, it isn't, but this is understandable because basically people are used to seeing code which looks like this, and they're not used to see code which looks like this. The amount of parentheses I think is actually the same, but they are placed at different places, and basically untrained eye is not used to see Lisp code. So people get a headache out of it, and then they say, okay, this is difficult because I don't have skill to read this, but after maybe a month you get quite used to reading Lisp. Actually nowadays I have difficulty with working in this. I don't want to go back to languages which have a lot of different symbols and you have to combine them in a way which is not clear, and things are overloaded, and in Lisp things are much easier. Like the entire Clojure is not that big. Like I will be showing some examples and you can probably get 50-60% of Clojure out of that, and there is not much more you need to learn. Like you need to, of course, get used to it and be efficient, and that takes some time. But now there are things like these, like you have a lot of parentheses at the end, and we have a lot of normal parentheses, and the C++ style are these brackets here, and then it's just different. I think people are people are not familiar with it, and that's the problem. So that's one thing. Another thing is Clojure is dynamically typed, and there is a lot of, I would say, mysticism surrounding static typing that it's somewhat beneficial. I would strongly disagree. I think dynamic typing is the way you want to go, because normally static typing is not really solving your business problems unless you do some type of work like you build your own compiler, and that's great. But if you work with data, then static typing is not describing your domain in a good way. You're much better with open hash maps than with classes and stuff like that. So OrgPad is quite big. It's maybe like 30,000 lines of code, which is comparable to 200,000 or 300,000 of lines in Java, C++. And I don't have any problem with getting around or understanding, or if I don't know what are some pieces of data, I can just take a look at them and see them immediately, and I can play around them, and the code is quite self-documenting. So yeah, I mean, normally static typing are addressing typos that say you switch functional arguments and then it doesn't work, and you say, what happens? And then you spend like 5 seconds and you say, okay, I switch functional arguments, but that's not helping you much. I would say there are systems where working without static typing is impossible because they're so idiosyncratic that you can't really get around it. Like at Google, we were using some libraries where I couldn't ever write a few lines of the nested objects without actually compiler telling me, this is wrong, I should put comma here and you should put it like that, because it was so stupid. Like I could never remember that. In Clojure, I don't have anything like this. Yeah, so, or you work in Java and then you have the similar stuff, but then like you use Java libraries, and then IntelliJ or other IDs come and help you the same as they would help you in Java. So, yeah, basically you can always work around with automatic tests and with REPL, which you will see, and there is also spec which you can describe the data programmatically and they can be checked and tested and stuff like that. Like, we didn't actually got much to these things except for REPL, but maybe we will add them in the future when I feel like the system is getting more complicated. Okay, so now last thing here is this thing called, I would say, like people use the names like functional programming. I think this is bad. What we really want is data-oriented programming. Like the first thing everywhere should be data, and the data should be presented in the form as it is. You don't have to wrap it in some ad hoc structures and create languages around them. It's just data. Like if you want to, if I give you a configuration file, you're much more happy than if I give you a program which would be generating configuration, because you can just look into the configuration file and you can modify the stuff and you can understand it. It's way nicer. So yeah, they can be printed, they can be analyzed. You have a single set of functions which you use all over your code, so you know how to work with a hash map. You don't know how to work with another class. You just have to study basically how to use the class. So there is this Eden notation. Clojure is written in Eden. You can think of Eden as an improved version of JSON. So JSON is good for data and bad for code, because for instance everything is string and you have to write commas and stuff like that. You don't want to code in this way. So Eden fixes that. It's also extendable. You can add new data types and things like this. And the amount of data types is a little bit bigger. So I think it's like hash sets and others. And yeah, let's see some examples. So this is a Clojure code which describes HTML application. So this is basically a form where you have hello, how much beers you have drink, and you have a button where you can drink a beer and it will increase the counter. So this is just a data description. This is a vector containing this symbol div, and then another vector inside, h1 with the title, and then b, and then the button, and this is basically the way how we describe HTML. This is called hiccup notation. So we have nested vectors inside of each other. And this represents, this atom thing represents a state. This is something which has some value and can be read and can be changed atomically. And this is basically what you do to generate HTML data. I would say this is way nicer than anything. That's a big problem. Like if you write a code, say in C++ or in Java or anything like that, which is supposed to generate HTML, it's really difficult. Either you do string concatenation, which is horrible, or you have to have some preprocessor like JSX for JavaScript, which basically inside of the JavaScript you start to write HTML notation, which doesn't really fit. It's really different. And then you continue, and then some preprocessing will replace the stuff and generate HTML objects for you. This is also horrible. And you don't really have nice ways how to describe nested data structures in these languages. But Clojure is built around nested data structures. The code is nested data structure. Now this is a list. So it's an opening list, then a symbol defn, which defines function, then the name of the function, then a vector, where there is a map, where there is a symbol, there is a vector, and so on. So this is a data structure. This should really be similar to stuff like JSON, but also it's a code. Yeah. So, and there is also this thing called object-oriented programming. I don't really appreciate it that much. I think there is some value if you do stuff like mechanical things, like some low-level API, or like think of Java API or a zip file or WebSocket or something like that. Then the mechanical things actually work. It's really bad for data. Actually, the creator of object-oriented programming was apologizing for the name object-oriented programming because it's really bad. He wanted to coin the term messaging, because the big idea is messaging, that you have components. Like, he was a biologist, so he was inspired by biological systems, which basically you have systems and elements and they interact with each other, messages. Like, think of something like internet. Like in the internet you actually don't communicate with objects, you communicate with text messages. Because that works, that scales. Like if you send some binary data to someone and the other side doesn't know what to do with it, like they're screwed. But you communicate with basically text messages, like HTTP protocol or JSON is, for instance, really big on the web nowadays, and it's basically text messages, right? Very simple data structures. Yeah, so there is also this. I found this somewhere on Twitter. So the idea of someone that this is how object-oriented programming works.
To be honest, I don't understand this metaphor at all.
Yeah, I think the problem is also the person doesn't understand object-oriented programming, because this like, the idea is like you have these pieces and so these are the objects and they sort of interact with each other and change over time, and so this is like the landscape of your programming. The problem is object-oriented programming doesn't work that way, because in fact it looks like this. You have this is an object and someone holds its reference. And if you hold a reference to the object, you're basically, they're like marionettes. You're the puppeteer master. Like you say whatever, you can control the object. Like so you can call some method on the object, for instance. But what happens in a real system is that multiple actors are holding the object. So you have basically this big spaghetti of objects holding each other and working at the same time in the multi-threaded system, and doesn't really scale. It's not. The real world doesn't work like this. Like say I want to turn the light here. It's not like I will basically grab his hand and will press the light switch. I will do it differently. Can you turn the light on? And you will receive the message and you decide whether you do it or not. So this is the real world analogy. Objects are not like that. I will call the method and it will happen. So yeah, they give you the illusion of real world. And all the examples, and when you have some object-oriented programming class at university, all the examples are super silly. And you don't do things like that in real programming. Yeah.
So basically what you're getting at is that what most programming languages try to do nowadays is let's not share mutable reference between different execution threads, but rather the message passing.
Yeah, this is something which scales. It scales to the internet scale, but you can also write the insides of your program in this way.
I think that's something done by quite a few languages, communities.
I mean, you can do quite a lot of these things, but the language is fighting you, because everything can mutate. If everything can mutate, you don't really know what's going on. You can't really believe that the value is the same, and you don't know who is holding the reference. That's the problem. You can be in this situation that you think you are the only one holding the reference, and then someone else will change it on top of you. So like, people are getting to this infrastructure, but I think it's more like fighting the existing system to get it. It's not helping you. But yeah, you can certainly program in this way when you do C++ or Java. Rich was doing that for 20 years. He was fighting the systems to actually work as Clojure, and then he decided, like, screw this, I will write my own programming language and will not have to fight it.
I guess he's referring more to languages like Haskell or Rust. Yeah. Which also address.
Haskell is different.
Yeah, both are very much different.
Yeah, I mean, I don't think they're mainstream.
Is Clojure?
Clojure is neither. Clojure is neither. I mean, I never did Rust. I did a little bit of Haskell. Haskell has its own problems, but yeah, it's.
I'm a little bit of Rust fanboy, so.
Yeah, I mean, for Rust I have never used it, so I don't have opinion on that.
I just think it's doing very similar things because, for example, it forbids that multiple threads hold shared mutable reference, for example, or stuff like that. I think it's getting adopted by more and more languages.
But you probably won't like it because with Rust you will be fighting the compiler.
Yeah, I mean, I would say in the end, like, I don't want to fight the system, I just want the system to work for me and just works better. But yeah, I mean, certainly these ideas are not unique in the way they are getting integrated to everywhere. Like nowadays you have functional programming in C++, and people want to do that. So
But
it's like,
yeah.
but it's really difficult to do good functional programming in C++.
I would certainly agree that if you look at newer programming languages like Rust or Go, they all just do
Yeah.
not object-orientedness in the same way. They do support it, but they go more for structured data, which is more important than
Yeah.
tying together function. And they also separate functionality from so like methods from the data. So this is they.
Yeah, I think they're sort of like half the way to Clojure. Like they still don't understand the full picture. They understand only half of the picture, and like they are getting there eventually. So that's how I think of that. But yeah, sure.
I think a really good example of things where you really fight the language is, for instance, in C#, but I guess in Java it's the same thing, of having objects in that way defined just by their values, and having equality, the identity defined by their values, which is intrinsically just works in Clojure, I guess, because it's built on those data structures. But you have to implement the adequate rule interface.
Yeah, I mean,
you have to do all this work, but this is essentially
Yeah.
80% of what you should be doing. You should be modeling the information and just be passing expressive
Yeah,
data
I mean-
structures, and that's a lot of work. And that's
yeah,
not
sorting
even
a
the
hash
same immutability.
sorting a hash map in C++. I still don't know how to do it. Like I could play around it, and maybe in half an hour I could get a sorted hash map. But it's a pain, and in Clojure it's like 3 words and it's done, because it's built in. Like you have to define a comparator, and then I have to remember like what comparator returns, and what how is the syntax precisely, and what is the idea of a comparator used in this particular hash map, and it's not super nice. Not something you really want to do. It's like you can get around, but yeah, it's very good. Now let's move on. I don't think this is so key. But basically, this is an idea of HTTP requests in Java, for example. It's not that much different in anything else I have seen. So yeah, you have how many maps you have here? Like it's really hard. They all behave differently. Like you have this basically mini language you have to learn every time you use an object. It's badly documented. It's ad hoc. It's different. It's really hard. It's life sucking. This is the Clojure way. Now if you think of this is a map. Keys, value, key value, key value. This is a map here, and so on. Yeah, this basically comes over the wire as a text. It gets parsed into this structure, and then I can manipulate it the same way as any other data structure in my code. So this is how you do programming in Clojure. And it's much simpler because you don't have to learn any language. This can be printed, examined. There are no surprises if you know this. There's nothing hiding here. It can happen here that I call something and the method has some side effects, or maybe something I didn't expect it, or it's really difficult to do. Here, nothing. It's just plain data.
This is actually something I thought the original Lisps did wrong, because Lisp just focused on being the list.
Yeah.
This example also shows that lists are not the most. So lists
Yeah.
you get you some
Hash
way,
maps are.
but you actually need structured data.
Yeah, you need structured data, and Clojure builds on that, so
You
it
need
takes the.
values and
Yeah,
just-
you have vectors, you have maps, you have hash sets also, which is important if you can distinguish vectors and hash sets, because if you have a hash set, you implicitly say the order doesn't matter. If you have a vector, you have to think, does the order matter or it doesn't matter? In JSON, whenever you read JSON or XML, it's so difficult because the order always matters. But it might not matter if you send data over XML, the order doesn't matter. But you can't be sure, and parsing XML is difficult, or parsing JSON is difficult because of that. So yeah, it's a little bit more rich than JSON, but yeah, sort of similar. And there's also this great 5 minutes here I would recommend to everyone who would want to hear basically how objects are really like bad life-sucking stuff, and you want to avoid it. And I'm quite happy that I haven't written any object in my OrgPad code, and we don't plan to. like there's some things you have to do because you work around Java and stuff like that, but it's not super pleasant. There's also this thing called functional programming. I don't really like the name because when someone hears functional programming, they can imagine something like you're programming with sign functions, or like you do the analysis mathematical class and you do programming with that. It's like stupid, and so it looks like something overcomplicated, and it hides actually that like that was the description I got when I was at high school. What is functional programming? Everything are functions. And you hear that and you say, like, okay, are you crazy? Like, I don't want to do programming like that. And there are like things like higher order functions like map, filter, reduce, and they're getting more and more popular, and this is the way how you want to transform your data instead of 4 cycles. And basically every modern programming language includes them, even C++. So there is, for instance, this Kotlin, on the Kotlin website there is it object-oriented or functional? And the answer is both. You can do everything. So it's like everyone nowadays wants to include functional programming. Like it's good that the industry is going in that way. But there is also like this mystique of overcomplicated. And I like this idea, like of Haskell. I think when I was at academia, like a lot of students I met, like when you tell them functional programming, they get sick because they remember their Haskell classes, and they didn't understand anything out of their Haskell classes. And like if you go to Java classes, at the end you will know how to do some basic app, like how to do a tic-tac-toe or how to do like XML parser or something like that. You learn this skill. And if you do go to functional programming classes, you hear these nonsensical words like category theory, monads, functors, whatever stuff. Like it doesn't sound super friendly, and like your reaction is, "Oh, I'm not doing that. I will go back to Java or whatever stuff." So yeah, in the end, I think really like the Haskell is actually harmful to functional programming because it basically pushes too much of stuff which has nothing to do with your problem, with your business, and you have to work around the compiler. I don't really see the value, at least not for type of things I am coding. Because the things I'm coding are like the business, like the nature of data is that it's sort of partial and it's ever changing and stuff like this. It's really difficult to capture this by types. So for the type of applications, really, like you should think Clojure is practical, transparent programming language. It's really easy to use it. It's really easy to get started, and it doesn't have anything overcomplicated there. You want to change the state? You just change the state. Nothing is stopping you. And so that's sort of maybe not so quick introduction, but let's get to some examples. So normally when you do coding, you run this. This is called REPL. You might know it from different programming languages, but it's very, very different. No other language has REPL. Like the normal REPL, you might think is like sort of a console where you can try out some code and you will get the answer. But the difference is REPL here runs connected to your application. So you have the full application running and you can change its code during the runtime. So normally I'm basically changing the code while the server or the client is running, and I'm doing experiments with it, and I have an instant feedback loop. So everything is connected. So let's see. So this is OrgPad. So now I'm connected to this application here. So I can analyze it, I can modify it. For instance, I can run a JavaScript function, alert, and it gets interpreted by the browser and it changes the browser.
So how does it know like to which process and thread to hook and when to break or how to emit an event.
I mean, there is a few servers running the compiler, and it does a few things. Like it reads the code. So let's.
Did you actually connect to your server-side application, or did you connect to the?
I'm connecting to both.
To Clojure script running in your.
Yeah, I'm connecting to both of them. So I have two repos. So one is connected to the server, and I can reload the code and change the code while running the server. And I have also one running to the front end. So this one is to the front end. So let's see, views. Is the.
You can see he had to run shadow/REPL double colon client.
Yeah, let's.
And so he connected from the Clojure REPL to his client basically.
No.
The client is defined in the configs hardware.
Yeah.
And there is.
Do we see something?
It's
Yeah.
on port such and such.
Okay.
It's on localhost.
Yeah. So now I changed the code. I added something to the HTML. The application is still running. I can do anything with it, and I can modify it here. Now I can maybe. Change the style. Yeah, and it's still running. So I can interact with it. I can examine the data. I can push some events or changes from the REPL, and so so this is really powerful. For instance, the hot code reloading. That when you do a change in the code, you immediately see the result, and the state gets preserved. So if I go and I open something, I can still do it like this. So now I'm in some state here, and I can do changes to the code, say how the rendering works, and I can see the result immediately. Another thing I can do is I can examine the state. So this is the full state of the client. It's a little bit big, but this is the full description of everything which is used for rendering. So there is some upstate which maybe tells you which mode are you in and what's drawn on the top, and some other stuff like for editing and where is the mouse placed and stuff like that. Where is the canvas placed? So where is the camera? How what is my zoom and so on. And so this is the upstate, and I have some information about the user. I have some information about the loaded list of documents, and I have the opened document here. So here I have that it had 3 connections, and then it has 3, actually it's 7 units here. So I can browse the data, and I can do some computations with them, say for instance, I can just get part of the map, and I can run some function on it, and I can see the results immediately. So this is a very tight loop you get with your program running, and you can sometimes of course use it as the normal REPL in other programming languages to do some experiments, like say I don't know what is say +1 and nil. I can just put it here, and I see that nil behaves as 0. So I can do stuff like that, but I can also like do the full interactions with the running system. I also have a REPL with which I can get to the production server. So if I want to say run some code on the production server, or say do some computation on the database, I can just run it in the console, and I can get there quite easily. So
of course, it's running HTTPS and so on.
Yeah, so this is the front end side, and it's done that it's running a few servers. So like one of the servers is looking at the changes in the source code and reloads the files and injects them to the JavaScript, and there's also some JavaScript code injected on the other side which listens to this, and then I have the communication and so on. And the tooling is really easy to do. Again, so they just describe the tooling by data. So this is a data description for the compiler, which basically describes like what is the directories of input and output and the resources and what optimization I want to run and so on. Everything runs as data. Because Eden is so universal, we use it for everything in Clojure. So we have configuration files written in Eden, and we have our static websites generated from data and so on. Yeah, CSS styles are generated in this way as well. Described.
So I understand correctly that you could use REPL?
Sorry?
Did I understand correctly that you could use REPL to run some experiments on your production server, for example?
Yeah, I could.
Which nobody sees, only you.
No, everyone. It's the production server.
Yeah, but can you do some kind of sandboxing for REPL?
I could run a different server for sandboxing, or I mean, we don't have the infrastructure set like this, but for larger companies they have like the sandboxing. Like I heard of some company where basically every employee can run a copy of every service where he does some modification, and then he runs the copy with respect to the rest of the system, and he can play around and interact, and you want to have this environment if you are supposed to code efficiently.
It is also done in Clojure.
Yeah, everything. Like normally you want to have everything done in Clojure, and it works well. And of course, like you can use any library from Java on the server, and I can use everything from JavaScript on the client. So we use React and we use material design components, and you can basically include everything from NPM, for instance. So you can really get stuff running, and that's important that it's practical.
Even on the Java side.
Yeah. So we can also run the server REPL. So now I am on the server in the development. So here, for instance, I can query the database. So say I want to know what are all users in my project. So I get the database queries. In this case, it's a sequence of maps. So from database, I will get maps. There is a small wrapper which allows you to write SQL scripts, and then it converts to Clojure functions, and then the data are Clojure data structures. So these are all users, org pages, the documents, yeah. And with this, it's the same type of data we have seen on the client. So all the functions and stuff I can do work the same. So say I want to know which IDs of org pages, or which titles are maybe IDs. So I can just map it, and yeah, sorry. I get a sequence of IDs, and I can do some stuff around it. Yeah, so I have a ton of basically basic core functions which run on all the data structures in Clojure, and I can use it when I work on a request on the server, or I work with database, or I work on the client to do some rendering, or I define how the data on the client should be processed, or I have the communication which is done in data, and everything works in the same way. Yeah, I can also do changes. Let's see. So let's say, yeah, there is this function which dashboard load, which loads the list of all documents. Suppose that I want to know what is the input, how it looks like. So I can just go here. I can write a log here. So I will log everything. So this is a pretty printing because it's an SD data structure. I want it nicely formatted in the output, and this prints to the standard output. So I am wrapping it with this function which says, okay, don't print to the standard output, but give me a string instead. So there's this thing. So now normally what I would have to do is, okay, I will stop everything and will reload the server. I will wait half a minute so it gets started, and then I can like restart everything and get it done. But that would be horrible. So instead what I'm doing is I can just load it like this. So I'm reloading this particular function. So now the code is updated and it already runs the new function. So now I can go back from the application. It loaded the list of documents, and then if I go to the console, and now I can see, okay, this is the data structure. Yeah, it's a little bit small and it's quite long, but basically here was the message which was there originally, and then this is the new message, which is again, it's a Clojure data structure. It's a deeply nested map. So I have some keys here, like what is the ID of the client, and maybe what event was sent to me, and so on, like cookies, and like the user agent, and these are HTML headers, and so on. So, I mean, normally you have special functions which you would be using to process this, but you don't have to. Like, you can just look at the data and then you use the normal standard things from Clojure, and you can analyze this and work with it, and it's quite easy. So basically, this approach works everywhere. Yeah. Okay. I don't know how much time we have.
We are at an hour, so we just spent 55 minutes.
One question regarding these deeply nested data structures. Assuming you probably write a lot of functions that require such data structures as input, but how am I as a user supposed to know which fields have to be populated, for example?
I mean,
how the structure looks, and how does Clojure handle it when fields are missing, for example? Does it just error?
Yeah, I mean, normally in Clojure the errors almost never happens, because if the field is missing, its value is nil, and most of Clojure functions are working with nils fine. So there are some situations where you will get null pointer exception, but in most situations, if you say I have a function which is called distance, and it takes a map and a key, and it will remove it from the map, so it will construct a new map without the key. Yeah, if the key is not there, it will work fine.
But what if you have a non-trivial function? What if
But if you have a nil here, it works fine. The output is nil. So nil is it behaves as an empty map. So in a lot of situations, these low-level functions are perfectly fine. This is called nil pruning. And then when you write your high-level functions, you normally also make it so it works fine. But yeah, I don't think it answers the question. So how you know what's happening in your program? Like, it's the general thing. Like, the types are not going to help you. If you open a project where you have 1,000 types and you don't know anything about it, what's going on, you are screwed anyway. Like, how does it help you that you know that there is a field which type is string if you don't know anything about what's the content?
I mean, that's the basic problem, like stringly typed stuff.
Yeah, but what will happen? What will happen? You know that the type is string. Yeah, good. But you will look at the name of that string, and from the name you will try to assume what's the meaning. In Clojure you have the names.
But I need at least know the field exists.
Yeah, but it might not, because the information is partial, and your system should work with it. I mean, normally what happens?
Between partial information and completely inconsistent information. You might have 5 different scenarios of inconsistent information, and you just map everything.
Yeah, but how types and listing of fields is helping you?
Like in your application, there's probably a method that renders org pages.
Yeah.
And if I pass to that method instead of an org page map, I pass to it a user map, then it would probably render either nothing or garbage.
Yeah, it will. But Okay,
Well,
compiler is not going to yell at you, but if you know the code a little bit, you won't pass it there. Because, or if I don't remember the code, I will just take a look what is the function. I will read it really quickly. And in the heading of the function, I will know what I should pass there.
Yeah, it's
Because
like 10
it's-
lines, so
Yeah, it tells you.
If all your functions are nice.
Like, let's say, let's look here, for instance. Okay, this is, maybe that's not the best example, it's a little bit overcomplicated. Let's go here. Okay, that's not good at all. Ah, let's stay where we were. Okay, so here I'm passing, okay, this is some basically object I'm passing in the entire client. So I very quickly learn what this affects. I don't have to study it, I know what it is. It's like one of the main objects which is passed everywhere. So, yeah, you could type it. It wouldn't help you that much. Like, the knowledge is anyway quickly obtained. Like, you see effects and you know what is it from name. And then here I'm saying, okay, this is a vector, and the second parameter is a map. And in this map, I am assuming that there is a link/id key. So, what is the input of this? It's a map where you have link/id something, and maybe some other stuff, which in this case is just stored. So this function is not asking what's there; it just stores everything.
Yeah, but then it calls another function now. I'd have.
Yeah, it calls this function. Yeah.
But then
So
I have to check that function, what it needs from those.
yeah, but
that data.
how types are going to help you? Like, if you have a big project where you have a lot of types and you don't know what's going on and what is sent where, you're still screwed the same way.
Well, but then I know where to look.
No, you don't. It's not helping you. The types are not helping you. I worked at Google. We inherited some project from some other team. It was like maybe 100,000 lines of code, and no one knew really clearly what it was. And we had to dig through, and we had some data which was changing over multiple years. And so you had fields there in protobuf which were declared, and you didn't knew what is there. You knew it is string, but maybe it's empty because it's obsolete already, or maybe there is always certain types of string there.
Yeah.
There is no way how you
You
can
had a lot of-
specify the
You had
information.
a lot of legacy code, but how would it, like, I'm sure it's also possible to write horrible code in Clojure.
Yeah, sure. But I'm arguing something else, and that's the types are not helping you on itself. You look at names. You have here names, the same way as you have them in your types. The problem with types is that it says that the container is more important than the data pieces. But with information, the data pieces are the important thing. The containers don't matter. I don't really care what's traveling together with link ID. It shouldn't care. The functions shouldn't care. I mean, so basically, if you do descriptions in Clojure, you do them on the level key pairs. So link/id means this thing, and you can specify it over the entire application if you need to. You can specify it in documentation. You can specify it in spec. In our case, documentation is fine because we can just get around and understand it. But
I had a question about that. I heard about spec and a talk of by Richard, where he presented it. But what was this signature definition, which is showed in the function definition? Do you want
Yeah.
to just open?
yeah, sure.
So that's essentially a definition of the kind of structure you expect. Am I reading that correctly?
Yeah, I mean, this is called destructuring. So it's basically does that the input is a map, and it will capture the value of ID and store it into the binding ID. So now I can use ID in my code here.
and everything else goes to link minus map.
Yeah, and this captures the original map. Yeah, I mean, basically what you could do with spec are things like, I will say the link/ID, the format is UUID and it has this structure. Or person/email is a string which matches to this regular expression, which is the regular expression for email. So it's not only a string, but you also know it's a valid email. And then you can use these things to maybe analyzing the data or asking, okay, this doesn't conform the spec, where are the mistakes? Or you can run it in automatic tests, generators and stuff like that. I mean, we don't really spend that much time with it because we have written the code in the way that we understand it. If your system behaves in the way that you do a change, and something else will randomly break, you're screwed anyway. So you should rewrite the system. You should fix it. It's like and the Rich Hickey had a great metaphor for this. This is something he called guardrail programming. Because there is one commonality of every bug in every software. It passes the compiler checks and it passes the test suite. Otherwise it wouldn't be a bug. But the bug is still there, you didn't solve it. And the situation is that in a lot of these big systems you get to situations that people don't really understand the system anymore. They just do some change and something else will randomly break. Then you're screwed. No matter what you do will help you. And the guardrail programming analysis is that you drive your car along the road and there are the guardrails aside which stop you from falling outside the road. And normally you just decide that you drive somewhere and you go there, but with the guardrails I would just be banging the guardrails repeatedly and would be saying, it's great that I have the guardrails here because otherwise I would fall off the cliff. This is not the way how people drive. So what you should do, if you have a big messy system, you should clean it, you should make it understandable. Because if you understand it, then you can be efficient and then you can do changes. So the situation in OrgPad is that I spend quite a lot of time cleaning the system and rewriting and changing the stuff so that we understand it. And in most situations I can understand it. Sometimes of course it happens that I guess you add more stuff or the situation changes, sometimes it gets more complicated and sometimes you get surprised by the system. But then you should always like think, okay, how can I clean it, how can I make it better?
Yeah, I guess my point of view was more from a library author's point of view, because that's what I mainly do, I write library code. So if you're the only the application developer who developed the code, sure, you know what it's doing, at least at the current moment. But let's assume you write a library in Clojure and you have users that are not that familiar with what your library is doing.
I mean, I have a few things what you can do. You read the documentation, or you read the code. In a lot of situations I actually read the code of the entire library because 200 lines I can read, I can check everything the library does and then I'm fine with it.
200 lines library is a trivial library.
Clojure is built around libraries like this, they're super efficient. Like super big libraries are a few thousand lines of code and Clojure is efficient in the number of lines and they're well documented and stuff like this. But like normally we have it like this. Let me give you a simple example, a comparison of Java versus JavaScript. Like JavaScript gets a lot of hatred, which is nonsensical. It's a much better language than C++ or Java. Because the JavaScript actually was Lisp originally. It was the guy who was creating JavaScript, he liked Lisp and he wanted to make a Lisp for browser. But what happened is that Java was super popular at the time, so his colleague came to him and like, okay, but I should like remove this Lisp syntax and put a lot of Java syntax there because it's more popular, and you should call it JavaScript because it's popular name Java now, so let's do it that way. But JavaScript is data oriented. You have JSON, you program in JSON there. It's not that far from the data structures we see here. So let's see.
JSON was more of a discovery that happened.
Yeah, but
was
yeah, but sort of like the data first and the stuff. So let's compare one thing. So we are using S3 storage in OrgPad. In the backend, we have. Where is this? Where is it? Util S3. So this. Of course, I'm just using the AWS S3 library, which is horrible. It's like the documentation is really bad, and like it couldn't get sense of anything. It was sort of like Googling randomly, trying to find out, like combining things till it works. So this is how you do connections to an S3 server. This is, of course, this is the Clojure syntax, but this is essentially, I'm creating this client builder object here, and then I'm calling this method on it, and then with this configuration subclass, with these parameters, and then I'm calling this method on it, and then I'm calling this method on the output, and so there's just a normal builder pattern written like this. I could never make sense of this garbage here. It just copied from somewhere like Stack Overflow or documentation. Like, I don't know what are these pieces. I have no idea what are these things. I do have objects like this. So this is the Java way, the object-oriented way, the old way, which I really hate. Let's compare it to the same like the library written from AWS again, but for Node. So this is the JavaScript library, and it's much nicer. Hey, this is the way how you do it in Java. It's the same code. AWS created an S3 object with these parameters. I have access C, secret key, endpoint region, some stuff like this. This is clear. I can make sense of that. This is sort of like Clojure. It's worse because it mutates and it doesn't have a lot of advantages, but it looks much nicer. It's much more understandable. So this is basically the way. Like, I don't have to learn a new specific language every time I do something. And normally with Clojure libraries, you just take a look at the documentation, you get a very good idea how is it used on examples, and they maybe even describe the things, or you look in the documentation strings and you put things quickly together. Of course, if the library is done well, you can also do it badly.
Yeah, but that still kind of assumes that programmers don't like just ignore the documentation or do silly errors. Because in the beginning, when I asked this first question about how to ensure that test maps meet certain requirements, you basically said garbage in, garbage out. Like
yeah, I mean, sort of like you can do testing. You can do dynamic testing in runtime. This is what you should actually do: testing in runtime.
I guess also fast testing and stuff like that.
Yeah, I mean, you have test suites, for instance. So you have automatic unit tests which will check that you're passing the correct stuff there, or some stuff like this. I mean, the problem is the object hierarchies and things like this don't really help you to understand the library. I really spent quite a lot of time putting this stuff together. I can read the documentation, and every object has 200 functions there with a cryptic documentation don't telling me anything, and how are they combined together? It's so complicated. Like, it's not helping me. The good libraries...
I disagree out of my experience, because that's just typing done bad. If you have your types done in a way that's expressive, and that it can really tell you what it's doing. For instance, I'm writing a parser at the moment at work, and if I have a call muncher, which has a function with the signature, it takes a token stream and gives me a result, and the result is the union of success and then a node type, a tuple of node type and the rest, and I know the rest is a token stream. I immediately know what it does. It takes something apart, it transforms it, and gives me the rest.
Yeah, I mean...
I would have no...
Yeah, I'm not saying that you can't write reasonable code, or you can write good code in typed languages, or everything you write in the dynamically typed language is great. In the end, the most dominating factor in every software project is the team who is working on it. If you have bad people, they will put stupid stuff in whatever tool you give them. If you have great people, they can write it even in C++.
Yeah, but you were making the point that typing is always useless.
No, I'm making the point that types are not helping you by themselves. In the end, you're screwed with types if they're done badly. You're screwed without types if they're done badly. So the argument was that the types will help you to understand. And I'm saying no.
Yeah, but I mean, that's true of everything.
Yeah, but then
I mean,
basically
it's like people who use IntelliJ but don't know a single key binding.
Yeah, but that's basically the argument is you're fine without types. The dynamic types in Clojure are not stopping you, or they're not making the code harder to understand. I haven't encountered this.
I mean,
it's like you have to write in a different way. Of course.
You have to write it well.
You have to write it well in every language.
Yeah, exactly.
Otherwise you're screwed in the way. And Clojure programmers are on average much better than average programmers, because almost no one is going to go through all of these things. It's not the most popular language framework, whatever, so only like the most... I would say the average Clojure programmer, and there is data for that, is much more experienced, and like maybe spent 20 years programming in other stuff and then switch to Clojure, and he's super happy that he switched to Clojure, and it's the situation.
I would agree that not having typing is not as terrible as most people make it out to be.
Yeah, that was the only argument.
Having a language with a well-designed typing system, which is very expressive, can also be very helpful and make types not useless.
Yeah, but I think it depends on the type of problems you're working. You said I'm working on a parser. And for parser, it's perfectly fine to type it, because you have pretty good idea what's the input and what's the output and stuff like that.
Yeah,
but if you work on the free data,
everything
which comes, information is not behaving that way. Processes are behaving. Processes can be typed, information not. Because information have partial information, have combination of informations. And how you type things like that, like how you type that, you have this piece here and this piece here together, traveling together. How you type it, you won't be able to type it. Yeah, but you have combinatorial explosion of possible types if you start doing this. So either you do the approach which was used in Google, that you have one big protocol buffer with 300 fields, where some of them are there and some of them are missing, and you never know which are there and which are not. Good, you know that there is this field of type string, but you don't know whether there is anything there. So you anyway have to read the code and try to look into the data and try to piece things together, or you end up with thousands of small types and they never describe what you need. So that's the problem is that with classes you put you say the most important thing is the container, but in Clojure the most important part are the pieces of information, and you can freely combine them and compare them and do stuff like that. And the hash map is fine.
But there's also difference between how heavyweight your type systems are. There are type systems, I mean Java for example, it's very difficult to create a new type. Or there's also no such thing as just an algebraic data type which is just there to loosely specify a schema. And so I fully agree, which is also a problem in most type systems where if you want to have a type, you have to parse the whole thing at once to get the full rich object out. But maybe your code doesn't need that. You just need, like in your example, you just need the link ID and you don't care about the rest. So I don't want to parse the whole thing. I mean, we won't settle the dynamic versus static typing discussion.
Yeah, I mean, it's
not today, because this is a discussion that never ends, and I guess everyone here has problems.
Yeah, I mean, basically what you can take out of this is we have a very big project in Clojure which deals with a lot of changing information, and I never came to the moment saying, here I'm missing types. Never. Because it's not a problem. Like when you start dealing with types, you spend your time with basically solving the type problems instead of solving the business problems. I don't want to solve any other problems than business problems. Everything I want to do ever is improving OrgPad, nothing else. Everything else is distracting me. And that's the situation, basically, that's my viewpoint of that. And of course, if you do something else than systems which deal with information, then you might be perfectly fine with type systems. Like a lot of standard libraries in the languages are perfectly fine. I don't have a big problem with, for instance, Java API, like how you work with streams and zip files and stuff like that. It's one way how you can write it.
I think that's the thing. The OrgPad project, you have a lot of different data there which you want to combine and present, and Clojure is used good for that kind of project. Yeah,
and Clojure was invented for this type of information systems living over a long time.
Information-centric.
Yeah. I guess it's just that the schema of the information is underdefined. You don't really know where you are going in the end. Like probably you are changing your schema from time to time and adding new features and stuff. Yes. Then it might actually be good to be able to iterate fast. But if your focus is more on, like, I really know my schema, and it won't change that often, but I need high assurances that my application will run and never crash and stuff like that. I think it's kind of nice to have a type system to like do proofs about variants.
Yeah, but you can. I mean, we could spec it. I don't see the value in doing it at the moment, so we didn't do it. Yeah, but if the situation changes, we might spec it and we might add testing and we might do these things. But I don't think the types will guarantee you and the schema will guarantee you safety. It's that's a myth. You still have bugs in software written in static type languages, and they do heavy testing. And I worked in Google, and then there you can't submit any line of code unless you have 10 times more lines of testing for it, because otherwise I don't know what would happen. The line might not be there in 10 days, but I still have to test it. And it was really slowing the productivity of everything, and it didn't lead to anything good. But yeah, I mean, they still have big bugs and problems, and they have to do a lot of things like running stuff in production and deployment. And they, for instance, they do stuff like they deploy the new features to only part of the users, and they test that everything is running fine, and only after a few days everyone will get the new version. Like if they would believe their type systems and their unit tests, they wouldn't do that. So I don't really think that it happens that frequently that you will send something to the part of the program where it expects something else. It happens if like you do a typo, you swap the arguments. And maybe you get some strange error, or you maybe mistype, you have some key and you mistype it somewhere and there is a typo in the name. And then you look into it, maybe 15 seconds, maybe 5 minutes if you do it stupidly, and they say, oh, it's here.
What if you commit and deploy it?
You should test.
Didn't you just say you're not testing it?
You should test your stuff before you deploy it, either automatically or manually. So I'm writing something and it doesn't work, and I see it doesn't work. I don't know why. I try to pinpoint it, and after a few minutes I will find out, okay, it's a typo in the name. Like, okay, I will fix it, and it goes.
Didn't you just say that you would introduce tests in the future, that you don't have tests right now?
I do manual tests.
Oh,
because
manually.
I do manually because the project, if I do change, and normally it doesn't influence some other parts of the code. If it does, it's something we should fix actually. If you do a change and it has an unintended side effect and you don't understand the code well enough, you should just go and fix it, because it will just make things more complicated in the future. So sometimes I will introduce a bug, and then we use it very frequently, so we will fix it in half an hour or something like that. Like if it would be something more production critical or stuff like that, we would have to introduce more testing and quality assurance and stuff like that. But we're still small startup, so the velocity of iteration is more important at the moment.
Yeah, this is actually the problem with side effects. Most of the time, you don't need to program side effects into your code. You have specific places in your code where you program these side effects, but this is not generally wanted. So if you do the straightforward way without side effects, you actually may understand your code.
Yeah, of course, I totally agree that side effects are shit. But
yeah.
But I mean, you know how it is. Usually, you can't really choose the code base you get to work on.
Yeah, we can.
Well, you can. Yeah, we can. Exactly.
Yeah.
That's the point, that you are in this nice situation where you can build on a green field your own system.
Yes. So yeah, that's our.
Yeah, that's the competitive advantage, that we don't have the shitty legacy code.
Exactly.
Yeah.
Because shitty legacy code is exactly where it's like you told us in the beginning, where you have systems which have 300 fields, nobody knows what they do.
Yeah, and you have this in practice. And
in 10 years, that's what your program will look like.
Maybe.
Because that's what all software looks like after 10 years.
Maybe. We will see.
Yeah, there are some questions, so go ahead.
I guess when you were talking about side effects, I think we can all agree that side effects in data are bad, but side effects when you change program code, I think unavoidable as soon as you share functions, for example. Let's say you have a very central function that can be parameterized and is different ways, depending on the context in which it's used, and you change this function. And now you have to basically retest your whole program. Is that something you consider bad, or would you rather have
you have to, but you have the same situation in static in all other languages and in all other situations. Like, okay, if you maybe remove a field, you will get a compile error. But if you say change some interpretation of something or some computation, or you have to retest it anyway. So normally, what you do, you just check every place where is it called, and you check that it works. And you actually want to understand the change, right?
You can actually check with live data. You can get your data from the REPL. You can run your function against the hash map that you got from the live system, actually. So you can, and because you are not changing anything, you are just transforming something that you are not putting back into the system. You can actually check your function against it. Of course, I mean, if you test S3, then you have to set up a copy of your S3 repository somewhere, or you have to make sure that you are not mutating live data somewhere for customers.
What about the polymorphism a la carte?
Yeah, that's good. But maybe just one point, like to close this debate, because I don't think we disagree fundamentally. It's just, I think, like, basically in my views, in a code like OrgPad, types would give you really little, and you would pay a lot for it. And what you would get is protection from things like typos. But the real errors are coming from completely different places. They come from places like browser, like threads in browser, and then the things how they're orchestrated and stuff like that. Like, so a lot of errors comes from, I don't know, like developers of Safari had some funny idea how they interpret some CSS rendering, and we don't expect that. Or maybe Google Chrome decides to not load fonts for you. So we do some computation of sizes, how things should be big, and while we do the computation, Chrome decides to change the fonts. And we don't have control. I get from the Chrome that it changed this font, and it still doesn't propagate to the rendering and stuff like that. So this is the real source of problems, and the types are not helping me with that. And these are the hell mistakes where you spend a long time like trying to figure that out, and this is like the real problem. So this in the end, I think this is the same in sort of every system, but if you want to solve them, you want your system to be as simple as it can be, and then your life is a little bit nicer. And I think Clojure allows you to have the system a little bit simpler. Yeah. So that's like, I think, the main message. Like, you can basically get the same stuff much easier, much simpler, much nicer, and then you can do it without it. Polymorphism. Normally. It used to be that inheritance was something which was encouraged. When I studied at university, we were taught inheritance, how great it is. I think nowadays it's discouraged. Actually, even OOP fanatics are discouraging inheritance. They only kept interfaces. So like multiple inheritance, it's hell, and like even non-multiple inheritance. Like inheritance, and normally the reason why you do inheritance was because you wanted to have polymorphic functions. So I want to have a function which behaves differently according to the type. But why should you need types for that? So what Clojure does is that it gives you polymorphic functions without types. They work with types if you want. So they have some kind of hierarchies which extend the types. So if you have types, say in Java, and you write something which works with object and you pass any object there, it will run. But also it can work with anything else. So yeah, let's see this example we have already seen. So there is this namespace, this package called OP, which are operations. So OP describe all operations which can happen on the document or changes. So say I can update the title, I can remove the document, I can add a new image, I can create a new unit, I can remove a unit, and so on. So each operation is described by a keyword and then based by some parameters. And I'm basically, when a client does an operation, it will apply it on itself, and it will also send it to the server, where it gets applied to the database, and it gets transmitted message to all the other clients, so it propagates, it works in the collaborative setting simultaneously. So I have this function here called OrgPage operation with this def multi, which defines multifunction. And so this function has 3 parameters. And this, it basically, there is this inner function here, which will do the dispatching. So it will take the input parameters, it will run some computation on them, and the result is used for dispatching which actual implementation should be called. So there is the default implementation, if no operation is matching, which will log an error. So maybe I forgot to add the operation or something like that. And then there is, like, for instance, creation of a new unit. So I will define a method of this multifunction, which dispatches of unit/create. So the operation ID is taken from the data. And then it will basically, it has these parameters, so unit has some ID and content and position and type, and then basically I will update the state of the DB to, like, add the unit there and do some, say, for instance, we do some rendering recomputations that we have some stuff on the server, like the core data, the raw data, and then we compute some stuff for rendering specifically for on the client.
And the DB here is the hash map, basically. That's
the effect.
The client state, the complete client state. So it's not like a SQL database somewhere. So
yeah.
Okay, but it's saved to disk automatically or something like that.
Sorry, what?
It's automatically persisted.
On the client, no.
Yeah, the server.
On the so this happens on the client. It will basically add somewhere in the deep nested map. So this happens on the client. On the server, it calls a similar multifunction. Here, there's this multifunction. Yeah, OrgPage operation working in a similar way, and it will call unit create unit, which is a wrapper for the DB SQL function. So it will basically call this DB/create unit, which will put these data values in, and then this is a Clojure wrapper for the SQL function, which we have migrations SQL here, units. So there is this create unit function. In the documentation I will describe what the function should be called in Clojure. Documentation string, and then these 3 SQL lines are called. So basically it takes these 4 parameters passed in. Yes, it inserts them here and inserts them into a table. So this is an example basically how multifunctions and the polymorphism is super powerful if you use it nicely, and you don't need to create type hierarchies to be able to do polymorphism. And this is something which Rich calls polymorphism a la carte. And it works. There is something called ISA hierarchy, where you can say that some value is generalizing some other values. So yeah, you can, and also it matches vectors, so you can have vectors of different values and they have to match all of them. So let me show you some other example. This is how mouse handling is happening. When I click on something or I drag something in the application, it will call me this uphandle function, which basically should do the effect of the change. So say if I click on a unit, it should open, or if I drag a canvas, in this case dragging the canvas, let's see. So I have this. If I go here and I do the canvas like this, so I have this data here now. Now if I will drag it like this, and I will compute it again, I get different data here.
The first value changed the
Yeah.
y.
The y value changed and the x value changed. The zoom is the same. If I will go and zoom it, yeah, the zoom value changed. So this is how the state changes, and so it's done by this multifunction here, and it happens on mouse drag. So if I drag the mouse, meaning that I press down, then move the mouse, and then press up, and it occurs on the element OrgPage canvas, and it can happen in any mode, and it can happen for any modifier like shift or control. Then I will do this code. Then I will look into the mouse down map at the positions, and then I will do like, and there is this thing that I can also be selecting a rectangle, like multi-selection of units. So first I will check whether I'm selecting units or not. If I'm selecting units, I will increase the selection. Otherwise, I will move the canvas. So this is how the code looks. And the dispatching here works on, for instance, this mode all. It generalizes mode view and mode edit. So basically the ISA hierarchy is allowing me to put here like the parent value. Like with sort of like with inheritance, but you don't have types. You can do it on keyboards or
So
similarly.
When translated into classic terms, we're defining a polymorphic a variant of up handle, and this variant only triggers when certain conditions are met.
Yeah,
so
and you have like maybe 150 of functions of this form, because every button has a different function and so.
So instead of discriminating by type and having different functionality, I have these discriminators. Okay.
So what happens if this discriminator defined in the end, like the drag and canvas and stuff, if like one function is defined of these discriminators of another function? Like what's the difference of these functions?
I think multiple of them are matching, you will get an error.
Okay.
And if none of them is matching, the default is called.
Okay.
And in this case, default means maybe I'm not doing anything, so I will just keep the state. But in some situations, the default could throw an error. And so now that's the thing, like if you have IntelliJ, you can use a lot of ID stuff you know normally from typed languages. Like say now I'm looking for mode all keyword everywhere in the source code, and I can quickly check.
More or less.
More or less. I think it's
Yeah,
not,
it's a bigger project.
it's not indexed actually. No. I think I changed the branch and it didn't index, so it's now indexing. But yeah, normally it takes a little bit, but it's big already.
Because there is some work on providing the same features for touch.
Yeah, there is like 147 usages, but there is this usage I wanted to show you. So this derive, this allows me to basically set the hierarchy. So in this setting, then I can use the ISA function. ISA function is you give it a child and parent, and it will tell you whether they are in the relation or not. So in this case, I will do mode/view, mode/all, and I will get true. And if I will say is view mode under edit mode, the answer is false. So this dispatching happens according to the ISA hierarchy.
That's very good.
Yeah, so
what
this
kind
is
of hierarchy is that? Because
sorry.
I don't know too much about the syntax, but isn't things after a colon just an identifier?
Yeah. What
without
is this? What are the types? I mean, normally you have strings and symbols, because you have them in all languages. So strings are strings and symbols correspond to something else. But if you think about programming, you need something more. And if you code in stuff like C++ or Java, you also have keywords, which are special identifiers, which are not strings, but they have special meaning. They are self-descriptive. So like for or while or if. stuff like that. So if you want to do coding in data structures, you need to have this class of symbols, and they are called keywords. And the name keywords is because they're frequently used as keys in maps. But they're sort of like, you could think of it like enums, but application-wide enums. So
Okay,
you
that
run them
confirms
across
what
the
I thought.
entire project.
Yeah.
And because you want to avoid collisions in names, like you don't want to have the same things, different things called the same, because otherwise like searching by the keyword wouldn't help me, then you have the name spacing. So the stuff before slash is the name spacing.
So
I can,
where does is A get the additional hierarchy information? Because these are just
there is some in this case some global registry which is stored. I can also build aside registries for different hierarchies if I
okay,
want.
so it's dependent.
But there is
on
some basically there is some
information.
global object which
Okay.
captures the hierarchy. Yeah. But in this case, yeah, the keyword is itself. So if I have a code like this, it will return the keyword. But it's nice. It also behaves as a function, which you can use. So if I have a map like this, I can use it as a function. Map is a function. So let's say I want to get the a value from it. So I can call it like this. But I can also swap this, and this keyword is a function which will take itself out of a map. So I get the keyword is called as a function, and it will get a map as a parameter, and it will find itself in the map. And this is super useful because, for instance, let's say I have all units in okay, yeah, okay, let's do it on yeah, okay, so let's do it on dashboard. That's there's some bug I should solve. Okay, let's say I have these org pages here, and I want to get their titles. Okay, so first I can just call the dashboard / org pages like this, and it will get me the inner map. Then I can call the values. It will give me the sequence of all values, and then I want to get titles. I want just to get so I can map it. And I will map, and now I need a function which will take the title from it, but it's the keyword. So I can just do it like this, org page / title on vals. And I will get the sequence of all titles. And now I could do some computation with them, or rendering, or whatever I want.
Then you could also restructure it using the thread macros.
Yeah, and because this is hard to read and you have a lot of brackets, you can just restructure it like that. So what is happening that you have the pipeline, like the first value, and then you apply this function on it, and on the result I will apply this.
Lift it a bit higher, there's a monitor on the way.
Yeah, sorry.
Ah, okay.
Yeah, so basically it looks like this, that I have value, and then one transformation, another transformation, another transformation, and so on. Yeah, and normally in Clojure you can even raise these things up, so you can, if you don't have any other parameter, you can just keep it like this.
Okay.
So you have nice things how you can work with the data structures. And another example, let's say I want to let's do it like that. Suppose that I have a map. So this is a map of from IDs to org page maps, and I can also map it. Okay, we need to do identity here. Let's not do anything, and in this case it transforms to a sequence of pairs, key value, and I can do some computation with it. So I can normally write here some function which will let's say like this. So I have this key and value here, and I can say, for instance, key is key and value is value, and it will transform itself to a different form. So I can write very nicely, very quickly things like this. Like compare this power with I don't know, functional programming in Java or C++. Like the amount of the code and the stuff you would have to write just for simple computations like this.
To be fair, C# has links, so.
Yeah, C# is still much longer than this. It's not that nice.
Yeah.
This works everywhere.
And this works for
it's concise.
And that's another thing. It works for hash maps. It works on vectors. It works on hash sets. It works on everything. It works on all collections in Java. It works on a lot of stuff. So
and you can use it in the JavaScript on your client. So you don't have to actually. You can use pretty much 90% of the time the same function that you have on the backend on the client as well. So, for instance, UID transformations, maybe because JavaScript they have no types for big numbers, big integers. It's a bad thing.
Yeah, but I mean, normally you have basically this cheat sheet, and there are like a few functions here what you can do with sequences and collections and so on, and you learn these things quite quickly when you code in Clojure, and then you can use it for everything.
And this is actually the whole thing, more or less. There is nothing else than this in Clojure, actually. So
yeah, this is Clojure script, and Clojure is a little bit. There is a little bit extra stuff because you have all the Java and
you
like
can
it's
show the cheat sheet for
yeah, it's just longer.
of course.
We
but
can,
it's, I don't know, 200 functions, maybe a bit more. But compare this to C++. I have
That's again everybody knows
or maybe Java or anything else.
Yeah, it's. I mean,
it takes years to learn such language.
Yeah.
And then you get this, and you know, in a matter of weeks, you know.
Yeah, in a matter of weeks you know basics, and in a matter of a few months you get really used to it, and you get super efficient, and then you just.
But is this fair though? I mean, I completely agree. This is a much simpler language. But the comparison from a function account perspective is a bit unfair. I mean, from a syntax perspective, that's a much better argument, because there isn't much syntax. Compare that to lambdas in C++, for example, which is a nightmare, which they manage.
And you have more syntax every year.
Type of phrase they manage to get into the syntax, which is really ridiculous.
But not even this actually. Like think of like the qualifiers in Java, like public, private, protected, whatever. You have like 6 types of these, and how they combine in different contexts. Like who knows that? No one knows that. It's like so complicated, these languages. And here I can learn it very quickly, and then of course mastering takes some time.
But that still doesn't mean. I mean, the concept of visibility is a very built-in stuff, which needs keywords and stuff in Java, and you could probably implement keywords in Clojure as a library or something like that, like visibility.
Yeah, you could. But the language is still quite complicated, and it will fight you. And that you can implement Clojure in Java. Like Rich did it. It compiles to Java.
No, I meant
so
you could implement something like visibility in Clojure, because if you wanted to.
You could, but you would end up with something which is complicated.
And then to understand it, you would have to read then the documentation of the guy who implemented visibility macros.
But I think try to code with immutable data in Java. Like do everything immutably.
Yeah, it's a lot of.
You're screwed because the collections are not immutable. And you have const and things like this.
Google library for immutable collections.
Yeah, but the problem is the collections might be immutable, but the objects you insert inside of these collections are not. So you might have an immutable collection of dates, but each date can be mutated, so it's worthless. in
that's
the end.
true.
So it's really difficult to do business logic in this way. So like basically you have the standard libraries and things set up in the language that you're assumed to program in a certain way, and if you want to program in a different way, the language is fighting you.
Oh, the standard library.
Yeah, the standard library and the standard idioms. Basically, what's easy is what will be done with the tool.
That's true, but
And what's hard is not.
immutability is making large inroads in Java. I mean, all the new date types, all the new file types are immutable.
Yeah, you can bring all of these things there, but in the end the system is really complicated and people don't understand it.
Right. It was invented without immutability in the first place.
Yeah, but I mean there is a value in the thing. There is not much in Clojure because you can learn it really quick. I think now you maybe know, like, I didn't went so much into the Clojure details, but maybe 30-40% of Clojure, and if you would spend another week you would know pretty much everything. It's not complicated language, and that there is a value in it. I don't like let me give you another example. There are Stack Overflow surveys, which I don't think they have that much value anymore, but basically in 2019 and I think even before, Java programmers were the best paid in the industry, like by a lot, because you have all these experts who can do the work of 10 people in other companies, so of course they are paid more and they know they are very skilled and they know it. And then they decided to remove Clojure from the survey and a few other languages. I think they removed Haskell also and some others. And what was the argument? That people use Stack Overflow very little with these languages, and then some people come and say, okay, people don't ask Stack Overflow questions for Clojure, therefore the language is dead. But I don't need to ask Stack Overflow questions because almost everything I know how it works. I can read the documentation and I know how it works, and I don't have to ask a stupid question, or it's something really involved, complicated. I have some problem with the compiler, which is like some update maybe broke something or stuff like that. Then I go to Slack channel and I will ask the creator how should I fix it, and he will sit with me and will fix it maybe in 5 minutes or 10 minutes. So you have things like that. I never will ask question on Stack Overflow about Clojure, and therefore the statistics is almost zero. But I go to Stack Overflow, I ask for Java questions, JavaScript questions. I can never remember which objects are used how, and I have to Google even the basic things there. So that's the difference. In Clojure, I just do the business logic and I know everything. And I'm not going to ask, okay, how should I do this feature in OrgPad? Should this button be green or should it be blue? People are not going to answer me that question, and this is what I'm solving in Clojure because I know the Clojure library. And
my original point before I went off the tangent was that this comparison is a bit unfair because the Clojure standard library does less. I mean, it doesn't do date time stuff and stuff like that because it can just leverage probably the JVM stuff. And I could use the same argument for C, for example, because I guess C has even less functions.
C is not that simple. Like you look at just at the operator precedence stuff.
Yeah, but the standard library, if you want to count the standard library, it has probably even less functions. It's because it's unfair. I mean, you can't do anything with just the C standard library. You don't have.
I think it's partially unfair. I think like still the same stuff in Clojure is much easier than in other languages. The same stuff, excluding the libraries. Like if I'm not comparing the files in Java versus files in Clojure. Because I will be using Java files, but I'm comparing like hash maps. Stuff like hash maps, like try to use C++ hash maps or C# hash maps, doesn't matter that much. It's a pain to do anything with them. Like getting 5 keys out of the map. It's a lot of lines and a lot of code you have to do. Constructing a map, difficult. Combining 2 maps together and sorting the map, we were discussing that as well.
Try to have polymorphic maps in these typed languages. You have to write your own, or you have to use some from some library, because they basically, if you take some map there,
something, and everything has the same type inside of it.
Or you can just have an untyped map if you like.
Oh yeah, no.
Yeah, you can do it in C#, but then you don't know what methods you call, so you have to retype it. So you can ask what is the type, and you can do like runtime stuff. You still have to fight the types, and it's not like people are not like think of like named arguments, like you do just position arguments in functions. You're not passing maps in between. And when I was, so I did most coding in C++ in Google, but it's not that different. And so normally what I would be doing, okay, I have maybe 5 parameters coming to a function, and maybe I will add another parameter and will call this function, and then add another parameter, call this function, and so it's like chaining like this. And if I could just have a map and add something to the map and send it next, it would be so much easier, but I can't do that. So I have to like have these ordered parameters, or I have to do the product types, where I will do the ordering, that I have a product type of these 3 things, and I have to document it carefully, that what is the product type, because I couldn't ever remember anything like that. So it's making these basic things hard for you, and then you're not doing them because they are hard, and it's easier to just write it as like 10 parameters sorted like that. So that's the message of tooling, basically. What's easy gets done, and what's hard people avoid.
So I think we are done, aren't we?
Maybe you want to explain a bit more about work.
Yeah, we can take a look. Okay, so OrgPad. So it's basically a platform where you can create visual documents, and you can share them with other people, and you can collaborate on them. And our goal is actually a little bit more. We would like to generalize and add more capabilities there. So like nowadays I do quite a lot of, we do everything in our startup there we can. So we do all the planning and business and coding and the documentation and stuff like that. But in the future I would like to do more. Like one of my dreams is to move coding there. So I would want to do coding graphically in this way instead of IDs. But also we want to do communication, and you can store documents, and you can store files, and you can store videos, and basically we want to change the way how work is structured. Nowadays the work is structured based on apps. So I have an emailing app, and I have a file app, and I have a document app, and they don't really communicate well with each other. I want to do it differently. I want to do, this is one project I'm working on, this is another project, this is my apartment maybe, or my house, or my education or something. I want to structure every work there. So I want to send emails for my work here, and I want to do the communication for my school here, and so on. So what would be the good example? Maybe, for instance, we were recently rebuilding the landing page for OrgPad. So this is a document where we were basically placing everything, like all the collaboration over multiple months were occurring here. So we are planning like things like which text should appear where, and we are creating our propagation video. So we built a screenplay here, and we uploaded documents and screenshots and recordings and
maybe I should
videos.
Explain, because I am actually the author of almost all of this. There are parts on specific tasks related to landing page. So this, what you see right now, is, for example, the video we did. So, and if you make a video, there are several things you have to do. It's a whole process. So first you have to know what you should actually say. Okay, so we did a manuscript. Maybe could you go back?
Yeah, sure.
Yeah. So so we did a manuscript. We basically said, okay, this first, then the second part, and then the third part. So we did the text. Then you have to plan the cuts, the visual thing, which will appear during in the process you're saying the text. So yeah, so we planted the cat. So we took some org pages and said, oh, okay, we will do, I don't know, this piece here and this piece there. Okay, so then we made some pre-work. So we did actually the scenes. Each individual scene is over there, placed in a file. Underneath the link to the org page we were talking about, and of course then you have to put it all together. This is unfortunate because this functionality doesn't, or this functionality isn't in OrgPad yet. So we did it elsewhere, but then you get the problem that we don't have a native voice. So then we contracted someone who read it out loud in proper English. And then we said, so there are the recordings then as well, placed to each scene. Then we put it all together again, and then there somewhere is the final 120 video.
Yeah, and you can basically, you have here a lot of files. You can upload them and you can place them to somewhere and link them to things, places where they matter and stuff like that. So you can, for instance, use it to organize your documents, but you can also combine things like you have documents and then you have some data and you put everything together and
you can show your trip to Japan maybe.
Yeah,
because that's more.
I mean there is the COVID information video page. We made basic information about the coronavirus and like the protective measures and the economic impact and sort of it's.
Maybe open up something.
Yeah, there is the interactive map and there is like okay, what are the types of the coronaviruses and why is it not just a normal flu and maybe basic protective measures. Like there are videos linked here and. Yeah, stuff like why social distancing is important and yeah, stuff like that. So you can build education materials. You can basically put related information together and it's in front of you visually. And you can share it with other people easily.
Yeah. You can do different tasks. So maybe these were actually two. Separate like examples of different tasks. So one was planning some big project. The other one was making a educational material. This one is another one.
This is a photo gallery / travel guide. I made it from my photos when I was traveling in Japan. So I have photos organized in the shape of the Japan map. And I was basically putting here a lot of information, tips where to go if you visit Japan, what was nice, what was interesting, and so on.
And you can also do when you put your org page together, then later on you can think about the story you want to tell and basically create a path through the graph.
Yeah, you have seen that at the very beginning.
So that's how the presentation, right?
So you would just present and you could also just share a link directly to the presentation.
Of course it works with the presenter and stuff like that. Like you can basically define a path through the graph, so you can do the presentation of the information.
If you want to.
Yeah, like say if you would wanted me to talk to you about Japan and where you should go for a vacation, I would just spend maybe 5 minutes, like prepare a path for you, and then we could go through it together. Yeah, it's not that
to be honest, that was really impressive at the beginning.
Yeah.
I saw the two and then it was.
Yeah, and you can basically like define a path like this that you say, okay, this will open here, and then in the next step maybe this will open, and then so on like this. And when I will play it will work like that.
That's really cool.
Yeah, so you can basically the idea is like we have a lot of different types of tasks, and we would like to combine them in one place where everything can interact with each other, and it will be nicer than using different apps for everything.
Yeah, I mean there are many use cases already nowadays. For example, some people already plan their research, academic research, in OrgPad. Others plan their bachelor thesis or these further thesis.
Master thesis, PhD thesis,
and so on. So yeah,
You don't care about backups. You don't care about stuff that isn't unimportant for the stuff. You can put everything in one place, and let us take care of
Yeah, but I hope you.
Yeah, we do. We have Adam for that. He's
Not
quite
we
German.
Actually, the productive infrastructure the account could be cancelled anytime. So we thought about that, and we actually have a complete backup of everything with a different provider, with a different account, bank account, and so on. So we can recover.
One interesting thing when I look at this org chart and this is at what do different arrow types mean? Do you have like different meanings of colors and arrows and all that stuff?
I mean, that depends on the creator. It's like you're free to choose whatever type of arrow you want, and like sometimes, some people create like red arrow means this and blue arrow means that. Others like don't care or just put some nice color on them, and it's more me
what
than.
I do, for example, is I split the topic which I'm working on into different parts, which are somehow related.
Yeah.
And I choose a color for each separate part, and then I just use the links in the color of that particular part. Right. But in future, I mean, we want to add like descriptions to links, so that might enforce the link.
Yeah, I mean, if you have some important link, maybe you want to put some information to it, like why is it so important, or.
I think it would make this whole thing very interesting if you could add meta information or like attributes to arrows and stuff like that, because then you're at a point where you can build queries that just query your graph and, for example, give you all the nodes that are in a certain relationship to each other.
Yeah.
Careful, you're reinventing data load and hypergraphs.
I mean, certainly in the future there will be an API where you will be able to read the data from some other software, or you will be able to put new data automatically there. So this is something we will support. At the moment it's mostly manually created, and it's more like as you work on it you will understand things better. So, for instance, Vita was talking about these colored clusters, and this is our IT architecture for OrgPad. So these are all the technologies we are using in OrgPad. So everything is centered around Clojure. So we have server, client. There is the React library here with some nice wrappers. There is some CSS generation, static web generator plus engines in front of the server. And then there is the server written in Netty and Clojure library ring, and there are some like handlers and Postgres database here and S3 storage, and then we have another server which is the screenshot server, which produces the images in the list of org pages. Because it's difficult to obtain images, so the best way is to have another server which runs Chrome, which opens the page, waits till it's loaded, then makes a screenshot and then closes the page. It's stupid, but there is no better way how to do it, and there will be more capabilities around this in the future anyway. And this server also, we have to restart it every day because otherwise Chrome will consume all the memory and
it will stop working. So it doesn't crash the core structure, the infrastructure or anything. It's a separate server after all. But
after some trials, like first we had one server, and then the screenshot server ate all the memory, and it crashed the OrgPad server. So OrgPad stopped working because the screenshot server was eating everything. So then we decided, okay, let's redo it and let's move it somewhere else.
There are entire startups only providing headless browsers for other people using an API because it's such a pain.
Okay, but are you actually spawning Chromium? I think I worked with something like that some time ago, and there was.
It's really not operationally interesting to run such infrastructure, believe me.
It's difficult.
Too many evenings that I wanted to have free using maintaining.
Yeah, I mean
so
there is this Puppeteer library from Google which allows you to control headless Chromium, but the problem is that it's a client application. It's not something you run on the server with a lot of independent instances, and there are difficulties.
Some people that have no idea about operational stuff wrote this.
Nobody
No,
ever
they
intended
never had a pager.
365 days a year. Nobody ever intended Chrome to do that, so it's not made for it.
I think there are actually prepackaged applications for that.
Yeah, that's
I remember using WK-HTML to image or something like that.
Yeah, it doesn't support modern technologies.
Oh, okay.
Yeah, you need.
For example, I mean, the mostly based on cancellation and
Yeah, you need to get basically the modern technology, like it has to look the same as the user would see it when they open it. And we will use it for more, like I plan to do PDF exports in this way, that we will screenshot the PDF instead of the PNG file, and we will do more stuff.
It has the best visual quality that you can possibly get.
So, but if I wanted to create an account, like, does that? I see you have an account there.
Yeah, I mean you can just so you go there and you just can register with Facebook
show
or
us the whole process with the landing page in the screen window.
okay.
Again, how much do I pay for it?
At the moment it's free because we didn't set up paying yet. We plan it to be accessible, so like really the basic usage for someone who doesn't use it that much, like maybe for some school project it will be free, and then the basic usage we think about €5 per month per user.
Yeah, but
and then like the scaling,
stuff.
like if you would want to do like more, like say you would want to have a team of people working on it and putting a lot of data, it would be a little bit more expensive.
You have some, but wasn't there something in the beginning where like all org pages were public or something?
No.
No.
Everything is by default is private, and
Okay.
you can decide that you want to publish either by link that is not displayed in the link of public org pages, or you can say, yeah, I want to really, this org page should really be public because maybe I'm publishing information about COVID research or something.
Okay.
Yeah, so you can
and everybody will be shown the public org page then.
Yeah,
But
if you want
it's
to make
really
an account, you can just continue with Google. You go choose your Google account, or continue with Facebook, or you can fill in your email manually, and then you're just in. You have your account. There's nothing like.
Yeah, with email is a little bit more difficult because you have to verify your email in your.
Yeah, you just click on it, but.
Yeah, I mean now I have an account created, and I can go and I can make a new document.
And you have like stuff like teams and sharing with specific people.
Yeah, you have. So you can create teams.
Maybe go share. Share.
Yeah, it's so you can. So you have to name it. So. So like this. So I can share it with specific people, for instance via email. I can also copy links.
Okay, cool.
So I can send this over, say, Messenger.
Yeah, you can embed it into your website if you want to.
Yeah, so if I have this, and yeah, this will work even if I don't have an OrgPad account.
Yeah. So you get this, and then you're in testing page.
Maybe you can show them side by side that.
Oh yeah, there is of course. This,
you can
simultaneous work support.
Kind of live update even when you're only reading it.
Yeah.
Okay.
So
so let's see. So okay, this is an anonymous user. Okay, I can create something. Yeah, I can put some content here. Let's say, let's go to Dresden Wikipedia page. Now I can just put the images there. It just works. I can change the colors, change how big is the title, can create a link, can change the default style.
the palette is already selected for you. It's harmonized palette, so that means you will not shoot yourself in the foot by
and you can
choosing
see
these
it's
colors.
getting
and so
updated
on.
here.
Basically, we spent like 3 days putting these colors together for you. Nobody will ever spend 3 days on making the styles for such a document. So the quality of the colors you will choose will be much worse. People create shit. Have you ever? Well, maybe this is a good metaphor for it. You have in your lives, you have probably seen many PowerPoint presentations, and unless they were like in Beamer or the same.
Unless someone really capable created the presentation, it's possible to do nice PowerPoint, but
1% or maybe even less than 1% of them were like professional, and the rest was shit. Like
it's really
rainbow coloring because I didn't want to have a
it's really difficult to do shitty stuff in OrgPad.
Okay.
So that's what
What if I'm colorblind?
It's verified by a blind, almost
Blind
blind
person.
user, almost blind user that can really see quite badly, and he has to like enlarge everything super large so he can like read it like that. And we let him look at OrgPad, and he has an account and like looks over it from time to time.
Yeah, it's like if people are blind, then they can't really help them with visualization. But
colorblind.
yeah, like colorblind or like having worse vision, like there are problems, and of course, like we didn't specifically address them, but it works reasonably well already.
So basically, the colors are set up in a way that they are like very far from each other, even if they look similar.
Okay.
So even blind people can, or colorblind people, I mean, can distinguish the, unless they are completely colorblind. Then I can't help them. Maybe the contrasts are a bit different. So.
Yeah, I mean, we put quite a lot of effort, and like, of course, down the road we will like do more testing and more like maybe some configuration that you will see. Okay, I see badly, and we will reconfigure the color for you and stuff like that. Like certainly possible. That's something which is in our current focus. Yeah.
Sure. Go ahead.
Talking about blind people, how well does it interact with screen readers and stuff? Because I heard you use Canvas for rendering all this stuff.
No, this is just something we call Canvas. It's plain diffs.
Okay.
But like we didn't do any optimization for readers, so.
We
Like-
don't have any testing users that.
Yeah, I mean, it's not something I would really spend too much effort right now. But like, of course, if the project will grow and we will do some optimization. But basically, it's just a plain HTML. So maybe your screen reader will be already able to read it reasonably well.
So maybe I should add up some like big picture to all of this. We want to make a tool in which you can do everything, and it's the simplest possible in a simplest possible way. So basically, what we intend to do is for the user to concentrate. The user should concentrate on his or her work, and everything else should be solved by us. So we intend to remove repetitive work which doesn't help your business, your thing you are doing in the software.
Yeah.
Okay. And the goal is to create such an easy app that even those who fight with computers on the daily basis, like maybe a generation or 2 generations older people than we are, even for those, we intend to make this app very accessible. So even if you fight with computers, with the basics, you should be able to use OrgPad very easily. And that's actually proven on many of these, because we have people using OrgPad, like many people using OrgPad who are way over 50, and they're fine with it.
Yeah, they hate other computer programs, and like they hate like using Word and these things because they're scared like something will break and they won't be able to work.
Or they will lose your thing.
Yeah, by the way, I was showing some features. For instance, you can import stuff from Google Docs or Word, or you can insert easily files and.
Yeah, that's what I wanted to ask if you have an undo button.
Oh, you have something better.
Yeah, history there is.
Will be soon. This is something.
There is a quick fix. One step back.
Yeah, it's something I'm actually planning to address maybe in a month or two when we're doing we are doing support with mobile phones. Right now it's not working on mobile, but it will start working on mobile maybe in a few days. The basic stuff and then the advanced stuff maybe in a month or two. And we plan to improve the text editor and improve the collaborative work so it works even better. And by the way, another thing you can also, if you want to export this stuff, I can just copy it. And then I can say create a new Google Doc.
Yeah, DocStitch.
I can just Control V here.
Nobody knows about this feature in Docs, but
I
he's a
didn't know
Googler,
that.
so.
Yeah, it's saying to me enable. No, it's
that's just bullshit.
Yeah, it's bullshit. Maybe.
What kind of format is this? Because it would matter to me to have a programmatic way of exporting it to something which is close to plain text.
I mean, at the moment there is okay, so there is a programmatic way to export the data because you can. There is an HTTP route, and if you query it, you will get the data in the Eden format. But like we didn't set up anything. Yeah, if you do, I think slash download.
Just do very stuff.
It opens you the download, and the download it looks like this. This is the Eden file.
Okay. I mean,
So
it's
you can
not like a stable version of API, but
yeah, I mean, API will come. It's not like the top priority at the moment, because we want to work on the core fundamentals of using it manually, but as the service will grow, certainly there will be very good API and the way how to query it and how to modify it, and basically you have to open it to other people so other people can write their own tools and improvements. And
by copying you get multiple formats in your what is it called in English?
Clipboard.
Clipboard, yes. Thank you. So you get this, and then of course you get plain text, and then you get some structured HTML.
Yeah, you get basically this, and you can copy it also here.
And that's the Eden stuff is for us, so you can copy between org pages very easily.
yeah, well, the use case I'm thinking about is if I want to do research there, I cannot depend on just you. I can't trust you to. Need to have local backups, even if it's something as stupid as I don't know. I'm sick for 2 months and I am unable to pay my subscription, and then I lose access or something like that. I have to be programmatically resilient against that. So it's not about copying visually. That's definitely a nice feature, but that's not the
Or you write the support, and we'll make sure that
of course
you get your data at least a few hours later.
Don't trust verify.
Yeah, I mean, we take care of the business quite well, and I mean, if something would happen with the data, I would be screwed. We would be screwed, all of us, because we have all the data there.
I don't care if you're screwed.
And but that means something, because we use the service, therefore we actually care that it runs well, and nothing is lost. And as Adam was saying, we have
are dependent on the running of our service.
Yeah, I know it's in your interest to do that, but still, technical disasters happen.
Yeah, as I said, we are actually geographically backed with a different provider, with a different bank account, with a different person even, to which it is written. So it's not like one person goes to jail and then everything is fucked
Yeah,
up
but I
or
mean,
something.
anyway, I understand the point. Like the same as if some company would want to start using it and would depend on it. They say, okay, we want to back it up in our way, and this is something not possible yet. You could program something which would query these things automatically, but it's not super nice. It will be possible down the road in a few months. So.
Yeah, especially with startups, there's always the risk of them running out of money or being bought, and then the company who buys them just discontinues the service because they just want 10 years or something like that.
Or the startup gets bigger and you have some sort of management coming up which wants to professionalize everything, and then you build constructs and do the backups actually.
Let's say it's.
Things can go
I understand this, but it's not our case because we actually take the security and it has to work. It's not a toy, and it has to work a really solid way. We are depending on it for already. After a few months of development, I was already depending on it for everything. So I was carefully checking that everything runs and when we use it. And we actually put way more work and effort into backups and security than do startups with hundreds of employees.
Yeah.
So
it's one thing.
It's running.
I think this debate is getting very theoretical because of course you're developers, it's your everyday's bread. Problems are your everyday's bread, unless I don't know. Yeah. Basically, it's like that. So, and you worry about our stability or something?
Actually, not anymore. But it's just a requirement I always have.
I would say.
I mean, I heard you, and I actually trust you on that level.
Well, I want to say this anyway. If you're so paranoid about your data, then you can't even you can't trust anyone. Like Google can go bankrupt. It's not that possible, I mean, but it's possible.
There's
decades or
stuff to
so.
do
It's
about it.
simply that we're developers, so we're control freaks. So.
No, but I mean, maybe Google won't go bankrupt. Maybe just Google will decide that your data is erased and screw you somewhere in the terms and conditions. Yeah, I mean, you have these things, but I understand that there are people who basically don't trust others and want to basically protect themselves, and certainly this feature will be implemented there, and we will have good API, and we will do things for businesses, maybe syncing to GitHub and stuff like that, so you can actually you can do the programmatic changes in your data, and you have everything back up in the infrastructure you believe, and that's of course our customers are basically in charge of the data. We are just providing the service for them. So you
can show the terms and conditions.
Nobody does that.
You can actually do that, and you can actually read those
because
they are in English,
and it's not. They are not very long. They're half a page long,
and half of it is explanation of the law. So it's
yes. Because we have
what we have GDPR compliant.
So yes, half of it is GDPR.
Okay.
Yeah, I mean basically, I never would want to do advertisement or selling the data or it's basically we are the servants of people who use the service, and that should be they should be in charge.
Yeah, this sentence says everything.
No.
All content in OrgPad is owned solely by its author or authors, in case you share it with someone. So yes.
How long have you been working on it?
So it's the idea started a little bit at the university. During my PhD, my unofficial supervisor was, I think he spent 40 years thinking how he could use computers to understand his brain better and how to explain himself and stuff like that. And over 40 years they came up with something which was close to what we have nowadays.
Show some of the pictures maybe?
We can. And if I go to my page and I do, I have my my CV done as really old version. This was done by some PhD student of that guy. He basically coded a basic version over weekend and then he iterated with a bit more. But like the user experience is super shitty and it's like it sometimes loses the data for you and stuff like that. You wouldn't want to trust the service like this, but it was good enough as a proof of concept, and so and you have basically like what I'm working on it. Like if you would want to understand me as a person, it's much better than a list of like I wrote these papers and I wrote these things and I maybe program these things and I spent this amount of years at PhD and this amount of years at Google. It doesn't really say that much. So this is more like description of myself. So yeah, I got to this. I really loved the idea because when I was doing research and working at university, I was thinking in this way, and the two allowed me to not do bullshit stuff like writing in tech and solving like how to insert pictures and how to order text and then so on. I could just like put the core ideas as I have them in my head, and it was so straightforward. So yeah, we were experimenting for a couple years on students, testing whether you could use it for examination, because for teaching it was difficult to change the teaching. Like this is the overall law of school. Changing anything else than examination is almost impossible. That's the reason why if you have like the school ministry, they will change the way how the final examination at high school is done, because it's so easy to change that, but changing how education is done, that's tough problem. So we couldn't push it to education, so we were examining students from something they were not taught in, and that was the big picture, like connections, like how matrices are related to linear mappings.
Maybe
and
you have the picture somewhere. You have the
It was
research
done
paper
manually
actually
on paper. So
Yeah, I mean there is this thing which is the OrgPad for.
but I meant the paper.
Yeah,
version.
but this is I saw both. Yeah, it will take a while. Okay, so that's. No, the research projects. Yeah, so this is a whole linear algebra looked in the software, and this is like what students were doing, like this type of form. Like, tell me everything about eigenvalues.
I think it's a really, really intriguing way to model thoughts or concepts, because when you think about all the alternatives, they're either linearly ordered, like slides or a document, you read from top to bottom, or it's strictly hierarchical, like a mind map in the strict sense. You go from the center to the outside, or I don't know, org mode trees or a file system. So it's a great blend.
Nothing complicated in life works in a linear or hierarchical way. It's much more complicated.
Or strictly. Basically, this is how your brain works. You also interconnect related pieces of information into a web, and then you operate within this web. So if you discuss something with somebody, then you go into this web, and then you pull out things you know and the related stuff, and then you construct your arguments from it, and you receive some other data and you store it inside this web. If it's something new, then you create a new node maybe, or you add it into some node that already exists there, or you rebuild the whole structure. And yes, this is how a human brain works. So it's much closer to what is going on inside your head.
Maybe show the presentation about the graphs that you'll.
But basically this what I showed. This is actually an entire book on linear algebra written in Czech for my students. So we have basically you just can use this. If it would work, I don't know why this doesn't work.
It's so big that it slows down this.
Yeah, this it was not built in this version of the tool, but basically you can have the entire book written in this form, and we actually had students who were using it. So basically we're running this experiment at university, and then both Camila and Vítě were participants of the experiments, and they really like this thing. I was also using it in my classes, and they liked the idea, and we basically started talking together, and in the end, like, we decided, okay, let's build a startup on it, and let's try to make it in the form that actually normal people will be able to use.
Yes.
Does this support like adding things like math checks or?
Not yet. I don't want math checks because it's ugly. But I mean, the problem with math checks is that it's inserted inside of HTML, and it looks really different.
Okay.
But overall, like, I want to have reasonable support for math, and not yet possible. But you can insert screenshots. So at the moment, it's at least possible to.
Yeah, maybe show the linear algebra or something like the proper version.
I have sent in the invitation.
The proper version?
Like the one with the screenshots from Camilla.
And there is also
this thing.
a conference presentation in OrgPad from a very different person, where Pavel actually was one of the
we can.
tutors.
Yeah, so this is another much like simpler diagram for linear algebra. This I created for Camilla when she was studying for the final exam at the university. So basically overview of everything. This is some part of the math, so you can find you can insert stuff like this. These are photos taken on the mobile phone, so you can do that, or you can insert images. It's quite easy, or I can always do stuff like this, that you will select something and then you insert it somewhere, and I can just insert it here.
Yes, images.
Yeah, I don't have the rights because I'm in the other account. Yeah, but okay, so I have basically this. The graph isomorphism. This is a project my former student did at the university. Some research paper which was presented at an international conference in this form. So there was this OrgPad presentation, and he was basically going through like the definition of the problem, like what is graph isomorphism, and some examples, and what is the problem he was studying, and further examples, and then comparing the problems and stuff like that. So this was a full presentation for a half an hour, and we have also video recording of that. So this is one.
You can actually see that on our YouTube if you want to, like the whole presentation in English. So if you're interested in graph isomorphism, then I'll go ahead.
Yeah, or if you want to see how it can be used for presenting it.
I would be interested in that actually.
Okay. I sent a link around in Telegram.
Oh, yeah, okay.
Yeah, so this is another use case.
And then there is a whole like set of use cases, like very very basic use cases. Like you have your personal agenda, like I don't know. You have 2 bank accounts, and you own a car, and then you own maybe a flat, or you rent a flat, and then you have to have insurances, and you have to have your documents and everything. And there are people who organize all of this in one place. So basically, you don't. If you have it in the paper form, in the most common form basically today, then you always look for something which is lost, maybe because you weren't that orderly and you didn't put it in the exact spot where you will find it later, or you are in a different place, maybe for example in the
vacation or something,
or maybe in the bureau or
for instance, this is an example. It's much older, so we didn't have files uploaded there. But I was using this to track my moving out of Zurich, where I was leaving Google back to Prague. And you have to think what you do with your apartment, and what you do with the furniture, and then you transport it, and who is doing that. And I have the paperwork with the insurance company, and I have paperwork with the bank, and I have to deal with Google, and I have to deal with the taxes, and what I have to do in Czech Republic, I have to set up bank accounts, and so you track everything here like this. So this was running live, and I was modifying it, and was crossing out things which were done, and so on. So you can use it for this everyday agenda very, very easily. We have other examples, like you can track documents for your apartment or for your car, like
Everything.
Everything at one place, and you can, and because it's structured as your brain, you can easily remember where everything is even after multiple months.
Yeah, and you have it everywhere. You have a computer, not just in some cabinet at in your home somewhere stored in paper
It's
form.
lot more protected than one paper copy in a certain flat. As you see in Beirut, you never know who ships what to the city and what then explodes and puts everything on fire, basically.
This is another example. This is the entire architecture of OrgPad in the detail way. Like the database here, and
why does it have to recompute the sizes when you load something?
Because browsers suck. Basically, the problem is that every browser is doing rendering in a different way, and also like you have the Chrome, but if it runs on Linux or in Windows, it looks differently, or on 2 copies of Windows for some reason it looks differently, and so you have to compute it on the start.
Okay.
And then it gets cached. So if I leave and reload everything, I think it should be.
And it's also much quicker when you like go out and in of one web page for yourself.
Yeah. I mean, there is some. It's quite involved, the computation of sizes, because you have like 2 dimensions and
But it's like
you
only
optic.
because you want the boxes to be like pixel perfect to the font.
Yeah, but I mean, normally you have 2 dimensions, so you have to specify width or height, and you want to do the optimal ratios that it looks nicely. So there is quite a lot of work for that.
And then Chrome decides to load the fonts a little bit better.
Do you help the user with the placement of the nodes? Because placing nodes on a planar graph is
So what
actually kind of
happens-
difficult, but sometimes you want to be like something nice to be radially aligned. For example, if I have multiple nodes.
We don't do like this type of stuff, but there is automatic layouting, because as I'm opening stuff, things have to move away from each other, because otherwise they will overlap.
Yeah.
So I have an automatic layouter. We've written our own, because nothing
It's a
which
hard problem
exists.
actually.
Yeah, it's a hard problem. It took me 2 months to do the prototype, so we have some physics simulation and computations of that. It's still not perfect, but it creates a reasonable result for now, and we will work on it in future. So yeah, if I will go and modify some things, I create a new unit here, things will move away.
Yeah, but it's
Okay, so
This computer is now also doing the recording of the.
Yeah. And you see like things will get closer to each other and stuff like that. So there is quite a lot of computation to get this running.
So do you also see the undo now?
we don't mine Bitcoin, we just mine coal while working on this project.
Yeah, so yeah, this automatic layouting was the hardest technical thing for. There's a lot of UX stuff. We do things like if you do incorrect input by a little bit, we are fixing for you. So it's actually like the tool is trying to predict what you want to do, but
true,
and this is a lot of tweaking. But like algorithmically, the hardest thing is the layouting.
do you plan to do some in the future to do some assisting for the layout? For example, sometimes people like to do a bit of a structure or snap things to certain. Also do.
Yeah, I mean the best thing would be if the layouter would basically learn how you want the things to be done, and then it's like nowadays it's assisting to you a little bit. So if say I don't want to have this here, but I want to have it here, and just move it there, and it will update. So it's not trying to say, okay, I don't want you to have it there. Sometimes it does, because sometimes it will jump back or stuff like this. It's difficult, but in the end you would want to make it faster, and you would want to look it nicer.
Yeah, because I personally have a slight stupid obsession with symmetry and stuff like that. So I don't like to like.
Yeah, if you're a pixel pusher, you have to be like Vita with very.
Yeah, I have managed to bend the system so that we made all the screenshots on our web page. So maybe, and it looks very good, but you have to rearrange everything, and then it fights with you because it moves. It says like, no, I don't want you to have it exactly here. I want it here.
I think the situation is if you give the user the possibility to do it manually, people will start do things manually, and you don't want them to spend time. Like, I want people to just sit and create the content. I don't want them to choose colors. I don't want them to choose positions. I don't want to choose the layout. I want everything done. But then you have to do it. You have to do it well, and then if you do it well enough, people will not complain.
For example, nobody complains about the way we authorize our units. Nobody even knows there is an authorize, but how are we doing this? How are we doing the thing that the units have certain layout? This is all automation. This and nobody ever complained about that because it's so good that you don't even realize it's there, and it's hell of work.
What is it actually based on? Because that's gonna bug me every time I open that. I will notice the resize now that I'm spoiled. Certain nodes are larger in font.
Yeah, it's. I mean, as Vitya was talking, it's possible to choose color and it's possible to choose the title size. And the idea is like color encodes in the way we use it. You could do it differently. The color encodes cluster, so everything here which is green is client. Everything blue is server, this is the static website, and so on. So you have blocks, and then like the key nodes are large, and like the smaller nodes, like less important things. Like this is an example of that. That will be small. So it allows you to say what's important, what's not.
That's a very it's a very good way to.
You can show maybe the styles.
Get the intuition of the user with a simple user interface, because
so you have just
choosing font sizes. The user intends to make that thing important, and your layout algorithm apparently understands that as in.
You have 15
I mean, you
colors.
could, but
you have 5 arrows basically, or 1 line and 4 arrows. Then you have just important path or normal path, and then you have 3 title sizes, and that's it, and that's enough.
Yeah.
Because if you need more. Like, if you need more points, more depth in your structure, then you are probably thinking too detailed, not general enough. Or maybe you should, it's a different thought altogether, and you should maybe choose a different color. And it's a different cluster of thoughts.
Can I have nested or
so it just
not
by creating some constraints.
It's something we also
you're
want, but
you from shooting yourself in the
priorities.
foot. And also
you have priorities.
Creativity.
I have priorities important.
Yeah, like now we need mobile. Basically, everyone wants mobile. I want mobile. I will probably buy a new mobile phone just because I want to use OrgPad.
I think that can
Yes. So
we come to nesting.
Yeah, we want to include nesting in the future.
Yeah, nesting and labels and stuff like this. And in the end, I would want the system to work that you can more combine. Now you have separate documents, but sometimes maybe you want something from there and something from there, and you want to combine it together.
Yeah, the idea is that you will basically get one org page. That's all you get, and that will be your dashboard. So because we do a system for ordering, and the documents are ordered in the old-fashioned table way. That's a little bit, like twisted.
For instance, what I hate about most of the existing applications is like you have these type layouts, but the problem with tabs is like the placement of things is ever changing. I can never remember here there is some file, so I have to go to this list which is not changing that much and find the file there, or I can type something to find it. But because I can't arrange things graphically, and if I open a new file, it will place somewhere and it will change the order of the others. So it ever changes, and I always spend a lot of effort and time just looking where is the file I want to edit. And sometimes I want these files, sometimes I want these files. So the file hierarchy is not helping because it's done in one way and maybe you want another way for the particular case. Like sometimes you divide it by type of the computation. Maybe sometimes you want everything concerning this part of the software. So all the types of computation for that. So you always are fighting with this. So we would want to have a system where it would you could combine things together and it would remember the placement. So it would be when you open it next time, it would be done the same. And you want to do this in the dynamic setting where things are changing, and so it's a really complicated problem to get it done well.
But I think we are getting there.
I have to leave.
Yeah, good
Thanks
night.
a lot for the presentation. Thanks a lot.
Yeah, thanks.
Super interesting.
Nice to
You'll
see
have
you.
my account tomorrow, I think.
Yeah, let us know to support at or
Yeah, just write us a
Twitter
message
or whatever.
if you would have problems with anything, and
just
quite quick in.
text us.
Thank you.
Yeah, thanks a lot.
Good night.